Compute primitive roots of Z and star. Primitive roots exist if and only if n is in the form 1, 2, 4, p raised to k or 2 into p raised to k, where p is an odd prime number and k is a positive integer. Let us consider an example. N equal to 10. Find the primitive roots of Z 10 star. Z 10 star is all the numbers less than 10 which is coprime to 10, that is 1, 3, 7, 9. These are the elements of Z 10 star. So first check if this n 10 can be written in the form 1, 2, 4 p raised to k or 2 into p raised to k. We can write 10 as 2 into 5 raised to 1, that is in the form 2 into p raised to k, where p is a prime number and k is a positive integer. This is the step 1. So, ensure n is in the form 1, 2, 4 p raised to k or 2 into p raised to k. Here 10 is in the form 2 into p raised to k. In the next step, this is step 1, and in the next stage, compute Euler-Torsion function phi of n. In our case, phi of 10 equal to phi of 2 into 5. Since 2 and 5 are coprimes, we can write phi of 2 into phi of 5, which is equal to 1 into 4. So phi of n equal to 4. The third step, find the prime factors of phi of n. Here this 4 can be written as 2 raised to 2. In general, the prime factorization of n gives p1 into p1 raised to k1 into p2 raised to k2 up to pr raised to kr. The prime factors are p1, p2 up to pr. In the next step, compute R1, R2, R3 up to Rn, where Ri equal to phi of n divided by Pi. In our case, in the case of 10, R1 equal to, we have only one prime factor. In the case of 10, R1 equal to phi of n is 4 by 2 is equal to 2. Only one R. In the next step, we will take each element from Z and star. For each A belongs to Z and star, A not equal to 1. No need to consider 1. Then for each Ri, that is, suppose if we have n Ri's, so I equal to 1 to n. For each Ri, you compute a raised to ri mod n. If the result equal to 1 mod n, if the result is 1 mod n, the element A is not primitive root. A is not primitive root. You take next A. Test the next element. You take the next A for testing. Test the next. This is the procedure. And in our case, we know Z star is equal to 1, 3, 7, 9. No need to consider 1. For the remaining elements, that is A equal to 3, you want to compute A raised to R1, we have only 1 R mod 10 equal to A is 3, our R1 is 2, R1 we have only 1 R, it is 2, then 3 raised to 2 mod 10 is equal to 9. This is not equal to 1. So 3 is primitive root. Take the next element, A equal to 7. Compute 7 raised to R1 is 2, 2 mod 10 is equal to 49 mod 10. It is not equal to 1. So 7 is primitive root. So 1 is primitive root. Then take the next element, A equal to 9. So calculate 9 raised to 2 mod 10, which is equal to 81 mod 10, which is equal to 1. So this 9 not a primitive root. If any of the Ri gives ARIs to I mod n equal to 1 mod n, then that element A is not a primitive root. So we are getting the primitive roots are 3 and 7. Then the number of primitive roots of Zn star is equal to phi of n. In our case, phi of 10 that's equal to phi of 10 is 4. Phi of 4 equal to phi of 2 raised to 2. Phi of 2 raised to 2 equal to 2 raised to 2 minus 2 raised to 1 is equal to 4 minus 2 is equal to 2. So set 10 star as 2 primitive roots. So we got 3 and 7 as primitive roots.